Hi guys, Shouvik and welcome back to our YouTube channel. So today we will solve another question from Leetcode itself. So let's get started. Yes, so today we have these problems like these things that is of max difference you can get from changing an integer, right? So yeah, on this problem statement they have given an integer num and we can apply the following operations on nums in two separate times. So before of that starting altogether the problems, these problems act as a medium and I feel so like it's an indeed medium problem and it is a kind of continuations of yesterday's problems only. And if you didn't see the yesterday's problems till now, so I will definitely encourage to you guys to see these problems. That is of, I think that is on yesterday only, on 14th June. That is a maximum difference by remapping a digits. That is of 2566 and this of 1432. Max difference you can get from changing an integer. So there is a slight variance of this which actually make these problems to a different difficulty levels. So I would definitely suggest to go to this video, like you can search on our channels for this Leetcode 2566 and you will get the video and watch this video at least one times, because the templates, the things that we have used here, that is just a like kind of upgradations of the yesterday's templates we have to do. So I'm not going to explain the template today. I'm just going to discuss what actually the extra delta we have to play of the previous question to this question. So what we have, you are given an integer num and you will apply the following steps to num in two separate times. Pick a digit x in 0 to 9. So what we can do, we can select the digits from 0 to 9 and pick another digits y from 0 to 9. Note y can be equals to x, that is y and x can be like identical digits, and replace all the occurrences of x in decimal representations of num by y. Like this way, let a and b the two results from applying the operations to num independently. So we have obtained two digits, two numbers, one is a and another one is b, and we have to return the max difference between a and b that we have to return. Note that neither a nor b may have leading zeros and must not be equals to 0. So that is actually the problematic lines or the creations of difficulty of this particular problems lines, because here we are not allowed to make any numbers to be equals to 0 or it should not have any leading zeros, right? So that is the reasons I am stating like it is a kind of difficult based on this statement only. So on this example test case you can see my num is 555, right? So what we can do in to select a, how we can get the maximum difference, we have to set our a to be some maximized value of the operations that is allowed. To that we have to set our a to be maximized maximum number, and to be try to set our b to some minimum number, So what we can do, the first time pick x 5 and x equals to 5 and y equals to 9 and store the new integer in a. So what it is become, it becomes 999, right? So you are replacing 5 to 9. And on second operations, pick x equals to 5 and y equals to 1 and store the new integers in b. So we have now a equals to 999 and b equals to 111, and the differences is 888. On this example test case you can see, so here you can see, you understood, right? So we are trying to maximize our a. So what is from 555, what is the maximum value we can achieve? 999. And what is the minimum value we can achieve so that it doesn't have any leading zeros, right? So that is a 111 and the delta is 888, so that we are returning. For this example test case, you can select x9 to be y9 so that it is maximized always, and store the new integer in a. And on the second times, x equals to 9, y equals to 1, so that b becomes minimized, and store the new integers in b. So now a is 9 and b is 1 and the max difference is 8. So I think the problem statement is like quite simple and straightforward, but actually the like implementation is actually the game here. So I'm just going to give you the intuitions here, what actually you have to think to solve it. So I think maximization's logic is going to be exactly same. Maximization's logic is not going to be changed at all, because on maximizations we are not going to allow any leading zeros, right? So let's take any arbitrary number. So let's number is 3 2 5 9 7 6 3, something like this, right? So to maximize it, we have to iterate from left to right. We have to iterate from left to right, and the first place where it is not equals to 9, because what is the maximum digit value? From 0 to 9 we have allocations, and what is the maximum value? Max value is 9. So from left to right, where we have the possibility to change any number from which is not equals to 9, we will going to change the first numbers from left to right iterations. The first numbers that we have the liberty to change to 9, we will target that only. So here 3 gets targeted, so we are going to change 3 to 9, and furthermore we are not going to change anyone rather than 3. On future, if we are going to encounter a 3, then only we are going to change it to 9. So our final result, the maximization case is 9259769. So that is the maximum numbers you can achieve from this number. So that is our maxi, right? It's clear. It's pretty straightforward. It's pretty straightforward. Now for mini, so that is exact same logic that we have saw yesterday. Now on mini, I am stating you have to do the same things. You have to do the same things from left to right iterations. But yesterday we have the liberty to change it between 0 to 9. So today also we have the liberty to change from 0 to 9. But you have to take care that the number should not have leading zeros. The number should not have any leading zeros. So now if I am going to change it to be 0, then it has a leading 0, which is not allowed. So then what is the liberty? Do we have the liberty to change from 0 to 9 for mini? For maxi, though we are using the 9, that is the max digit. But for mini, do I have the liberty to change it to 0 to 9? No, because it may in most of the cases it will give you a leading 0. So for mini, I am giving you the liberty from 1 to 9, right? So on the very first place, from left to right iterations, the very first place where you are getting a number which is greater than equals to your 1, the digit that we have encountered from your left to right iterations, the digit which is greater than equals to your greater than 1, which is greater than your 1, that is my targeted digit. And I will going to change it to 1, not 0, because for mini we have the liberty from 1 to 9, not 0 to 9, because that will going to incorporate leading zeros. Agree guys? Agree? Totally agreeing. So it is going to be changed to 1. So for me, and it is also going to be changed to 1. So for mini, it becomes 125971. So that is our mini. Right? So that is one possibility. But mini have another. So let's suppose take one more example test case. Let's suppose we have 115795, right? So now from left to right we will iterate and we will find the first numbers which is not equals to greater than 1, we will change it to 1. So ideally you are going to select this number and change it to 1 and all of its successive occurrences also. So it becomes 11790, right? It becomes 11791, right? 11791, right? It becomes 11791. But is that is my mini? Is that is the minimum numbers you can achieve? Is that is the minimum number? No. That is not. So if I am going to change it to rather than 1, if I am going to change it to 0, then what is the number I am going to achieve? 110790, which is also minimum, which is also less than my mini, which I am able to achieve by changing it to 1. But changing it to 0, I am getting more minimum number. So ideally, in this case, my mini should be this, and it also doesn't had any leading zeros. Leading zero we don't have. Don't have, right? We don't have any leading zero. So what is then the algo, Shouvik? What is the algo? What actually the intuitions for mini? So maxi, it's very simple. The first number which is not equals to 9, we will change it to 9 and all of its successive occurrence to 9. So for maxi it's very clear, Shouvik. But for mini we have two cases. So on one algo you are stating from left to right iterations we have to find the first numbers which is greater than my 1, and I am going to change it. To 1 only. Like this way we will get our mini. But this is failing for this example test case. So on this example test case we have the liberty to change it to 0. So on last example test case, if you remembered, we have decided we have the liberty to change it from 1 to 9. But here I am getting the liberty to change it from 0 to 9 boundary. I am able to select the 0. Right? So what is actually the algo? So it is very straightforward maths, guys. So here I would suggest, so what actually the algo? So if I have at least one from left to right iterations, then I'm not going to change it, because if it is not equals to 1, greater than 1, then only I'm going to change it. But here it is. We have already skipped 1. So that I am not going to get on the state of leading zero incorporations. I am not going to state of leading zero incorporations, right? I am not going to incorporate leading zero. So that checks is already done. So if your number is starting with at least 1, if your number has at least 1 from its left to right iterations, then we are not going to change the 1th occurrences for sure, because if we change 1 to 0, it will incorporate leading zeros, which is not allowed. But after that, after this 1 incorporations to any place, we have the liberty from 0 to 9. We have the liberty to change it from 0 to 9, and the first numbers in which we are going to see it is not equals to, not equals to 0, we are going to change it to 0, and we will store it that for any successive occurrence of these numbers, we will going to change that to 0. That is the meaning. So here in this example test case you saw, right, we have changed this 5 to 0 and also of its successive occurrence, so that we got our actual meaning. So that is our actual meaning. But there is a small point. I think this example test case is going to be best suit here. 115,795. So what I am stating, if you have find at least one, then to its right, you can play the yesterday's game. What is the yesterday's game? You can select any number, the first number which is not 0, you can select that number to be your main change, and change it to 0, and all of its successive occurrence also change it to 0. But there is a small case on this example test. Okay, Shouvik, we have encountered a most significant bit has 1. So as per your algo, all of its right, we can use the algo. So what is the just right of it? It's 1. So then if you are writing that algo, right, after getting the most significant bit to be 1, to its right, whomever the number first is non-zero, we will trigger the 0 to be on that particular index and all of its successive index. But that is an exception case. So if it is 115, like if we have multiple 1th occurrence, so that means what actually this means, we are not changing 1 to any other number, but here if you apply 1 to 0 here, so that means this one you are changing to 1 to 0. If you are changing those, so that means we are inherently changing this also, which actually incorporate leading 0, so that is the extra checks you have to take care. So if you are starting with leading 0, then all the 1 occurrences to the index in which 1 has occurred, you will not going to play the game. That is of the first numbers which is not 0, you are changing to 0. The first non-zero change to 0. So that is our game. If it is starting with leading 1, then that is our game. But the exception case is, and the most important case is, skip once, because one should be skip once. One should intact. One should not be gets changed. That's it. That's the games you have to play. So I think that is all about the intuitions. Now we can quickly go to the code iterations part. So on code iterations, you can see we have declared all the variables that we done yesterday only. I am playing the games with string, y string. We have already explained. I will definitely suggest to watch that yesterday's video. That is of Leetcode this 2566. So now I have converted the strings to its string versions. My mini to be empty, maxi to be empty, mn1 change to be -1, mn2 change to be -1, mx change to be -1, ok1, ok2, ok3. So this actually means, do I have the how many types of operations we can perform. So for mini, we have two kind of operations to perform. Either it is starting with leading 0 or it is not starting with leading 0. So that's the reasons I have taken two flags. One is for like first operations, that is of not starting with leading 1, and second one is for starting with leading 1, right? And the third one is for maxi. So for maxi, we don't have this kind of checks. We just need to find the first occurrences of non-9 and change all of its successive occurrence, including that to 9, right? So for maxi, we have the simple. So only OK3 should work. But for mini, we need two flags. So I am iterating for each in my string versions of num, and if OK1 is set, so that means operations is operation 1. So that means it is not starting with one case. It is not starting with one case, not starting with leading 1 case. So if each not equals to 1, so I got my guy. So mn1 change to be each, mini to be plus equals to 1. I am changing it to 1. So that means it is not starting with leading 1. OK1 to be false. Else my mini to be plus equals to 1. So that means it's starting with 1, right? It's starting with 1. So how we then OK2 changes we have to trigger, right? OK2 changes we have to trigger. So how we can then jump on the OK2? So just marking OK1 equals to false, because we have only two operations on to convert to mini. Either, so both are mutually exclusive. So what are the two operations? Either it is starting with leading 1 or it is not starting with leading 1. So if it is on else block, so that means it is starting with leading 1 only. So now if OK1 is true, so when OK1 is true, so when it is not starting with leading 1, so on that particular case only we are triggering our OK1. So to go to its OK2 block, we if it is starting with OK1 or it is not starting with OK1, we have to stop the leading 1's block. We have to stop the non-leading one block, so I am marking my OK ones to be false and mini to be plus equals to 1 because it is starting with leading one only. And on elif block, when I can predict that my OK1 is false, is not sufficient, right? So OK1 is false means I am triggering the go with OK2. But there is an case like OK1 is false because of actually we have found it is not starting with leading one, and we are changing the occurrences of, we have found one guy which is not equals to 1, and we are changing successive of all of its occurrence to 1, to change all of its successive occurrence to 1. So how we can decide? So on that case, my mn1 to be set, right? mn1 to be set. So on else, it is not a standard else, we have to put inside an elif. So how we can check if it is set by our OK1 or my OK1 is not at all valid. I am performing the operations of mini to be OK2. So that means it is starting with 1. How we can differentiate? So the differentiated factor is my mn1 should be set. So where the default value we have set to be -1. So if it is not equals to -1, so that means OK1 is set by mn1 is set by non-leading one. So this number is starting with non-leading ones, and we found one guy which we can convert to 1 such that we are going to get the minimum value, and we have to replace all of its successive occurrences. So on that particular case, we have to go to mn1 is going to be set. And we are performing if each equals to my mn1, then I am appending my mini to be 1, else as it is each. Now on elif, see, so every of these if and elif are mutually exclusive. Either of one should be true. So these are mutually exclusive blocks. Now if my OK2 is set, so I can't predict if it is going to be actually on the OK2. I'm not sure if it is actually going to be my OK2. I'm not sure because OK2 is maybe set, OK2 may be set when my OK1 is also set, and maybe OK1 is false because of this, because it is starting with leading one, so in that case also my OK1 is false, and we are going to jump on this OK2, and also we are not setting our mn1. So how we can decide? Either this block executions is either via this, because it is starting with leading one, or it is coming via this, so how we can predict? So that means, sorry, not this. So either my OK2 is going to be true. How we can predict this? So either it is coming by leading ones, or it is actual my OK1's block. So OK1 is set, and also OK2 is set. OK2 was set because my OK1 is just false, but OK1 is false because it has some leading ones. So what is the delta? How actually I actually know if OK2 stands for it is starting with leading one. OK1 stands for it is not starting with leading one. So how I am going to sure that my OK2 is true and it is not starting with leading one? Sorry, it is starting with leading one, because OK2 is only, this block only gets executed, these blocks only gets executed if it is starting with leading one, only. How I am going to make sure that OK1 is false in both the cases. OK1 is false in both the cases, right? Either it is starting with not leading one, or it is starting with leading one. But how I can get the gist? What is the changing parameters? This mn1 only. See guys, because others are mini plus equals to 1 in both the cases, OK1 is becoming false on both the cases. So only changing parameters, only pointing parameters, only directing parameters is mn1. So if it is starting with leading one, then I am not setting my mn1. But if it is not starting with leading one, then I am setting my mn1. So if my mn1 is not set, my mn1 is in default, so that means I have allowed to permit my OK2. So to permit to OK2, we have my OK2 to be set, and my mn1 to be in default. So that actually the indications that I am starting with some leading ones, right? So if it is leading ones, so now that case, right? So after leading ones, we got another one. So if it is 1, so if it is starting with leading one and each is 1, then we already discussed, right? We'll skip all the 1th occurrences because on 1 should intact. So if it is 1, then mini plus equals to 1, nothing. If it is not equals to 0, so it is not 1, not 0, so then only we have to set our mn to change to be each equals to mn to change, and mini plus equals to 0 and OK2 equals to false. Else my mini plus equals to 0, else I can go with my mini to be plus equals to 0. That's it. So it is already in 0 maybe. Now elif when I am going to execute. So here you can see when I am allowed to use my mn1 change, when my mn1 is not in default state, that is it is coming by OK1 non-leading one start, and when my mn2 is going to be set, when it is coming to leading on start, and we found the indexes where it is not equals to 0 also, and we set it. So on that case only we are going to check if my mn2 change is also not equals to -1. If my mn2 change is also not equals to -1, on that particular case only we are using our mn2. If it is mn2, then we are changing it to be 0, else we are changing to whatever it is. Now for OK3 I have used the exact same code that we have written on yesterday only, but let's just quickly iterate. So if it is not equals to 9, then I am going to set my mx change to be each, so that on any successive occurrence, if I am going to encounter any mx change, I will replace it to be 9, and I am setting my maxi to be plus equals to 9, and I am OK3 I am making it false, else it is indeed a 9. So on that particular case I am consuming that 9 to be my maxi. So on else block, if this number is equals to my mx change, I am going to change it to be 9, else I am just consuming as it is. And finally I have my maxi to be the max numbers, mini to be the min numbers, and what I am doing, I'm just returning the delta. So that's all about the code iterations. I understood this particular if else mutual exclusions is actually a kind of very tricky to implement. So that's the reason it is tagged as a medium difficulty. So actually if you are missed any mutual exclusionsness of any particular blocks on the mini finding, then you are going to get a wrong answer for sure. So that's the reason it is tagged as a medium difficulty. So you have to be very conscious to play with the games to your mini, so that it is jumping on the mutual exclusive blocks. Not like you are consuming mini with OK once, you are consuming with mini with OK2, then you are going to get a wrong answer for sure. So mutual exclusionness is actually the game. So everything's under if elif block. So that means every block has some sufficient requirements to get it executed. Based on that only it is going to be executed. Else it will not. Right. So that's all about this particular question solutions, guys. Now we can quickly discuss the time complexity. I am not going to discuss it at all, because the time complexity is exact as it is of yesterday that we have discussed, because we have done exact same things. We have converted a string, then we have iterated over the strings, and finally we are returning its inversions. So the time complexity is bound to be exact of same only. So time complexity is big of 32 and space complexity is big of 40 only. And constant also is same, that is of 10 raised to the power 8. Yesterday we have it. So that's the reasons, like the same games we are just playing, but the mutual exclusions things is actually make these problems to a different difficulty level, so that it is tagged as a medium difficulty. So that's you have to just to be take care. So yes guys, so that is the time and space complexity that you can achieve, and I am pretty sure, like 100% sure that is the most optimized time and space complexity you can achieve for this particular question solutions. And you can see like our submission is altogether 100% faster than all over the submissions over the Leetcode, and it is indeed to be like constant time and constant space kind of solutions only. Yes guys, so that's all about this particular video, and I have tried my best to make your doubts to be on different clarity levels, to make the things in the more granular plate to you, to explain how actually the mutual exclusions you have to play with in the code iterations. And if you guys are able to understand till this point, I guess you guys are all reading. So please guys, please do subscribe to our channel, and please share the videos to your friends circle who are also preparing for top product based company and brushing up their TSS skills. And please turn on the notification, so that when we are going to live to our next video, you guys are going to get the notification as soon as possible. So that's it guys, that's it for today. Let's meet tomorrow with another video. Bye guys, bye.